today in the yellow box. Okay. So for module A student, I only ask you to understand module 1 and module 4. Okay. For module B, module B student, you have to learn all 4 of them. Okay. All right. So what are they? Module 1 is testing the moderation effect within the symbol moderation. As I always say, symbol moderation. Module 4 is used to testing the symbol mediation effect. Okay. For module 6, this we call serial mediation. Sorry, not mediator. This one is serial mediation effect. Serial mediation effect. Okay. And this one is mediated moderation or moderated mediation. Okay, I will talk more about this. Why I say like this in the next class, okay? Because these two, theoretically, they are different things, but statistically, they are the same thing. Okay, so far. All right, except if you use, this is the interesting thing. I used to wonder why they are theoretically different, but they are testing the same. So I wonder whether I can test their two natures. So when I use M-less, I can do that. Okay, I can, using M-less, I can calculate the mediation effect first, then moderate it. Or I can calculate the moderation effect first, and then mediate it. Okay, so that's the only R or M-less can do that. Okay. So let's go to some theoretical discussion about bootstrapping. Process is not the methodology. Okay, process is just a tool name. Bootstrapping is the methodology. For example, regression is a type of testing methodology. Spss is the tool. Okay, so you have to understand the two different things because many students, maybe because you keep hearing that process or Spss, you thought that is a type of methodology. It's not. It's just a software name. Okay, you can test the regression, you can test bootstrapping using many different software. And process is one of them and the more convenient one. Okay. The basic of bootstrapping, in this one, resampling. Okay, resampling technique. Resampling means that Resampling means that, let's say you only have 100 samples, okay? You only ask 100 people. Each person, you ask about 50 questions, okay? So for bootstrapping, they will try to regenerate the data from 100 samples, they randomly make it into 5,000 samples, okay? And from 5,000 samples, they will try to find a pattern under the 5,000 samples, okay? So if you ask me how they do that, I'm sorry, I don't know, because I'm not do not research into research methodology. Rather than I try to understand the method and apply it to the testing. So you may heard about Monte Carlo, okay? So around 5 years ago, in our field, in the business, we tried to find a way to solve the problem. At that time, only Monte Carlo seemed to be able to solve our problems, okay? But the problem is Monte Carlo required an underlying presumed understanding already. That means you already presume that there's something like that happened. So you can test using Monte Carlo. Okay. Some very complicated, for example, like let's say serial mediation double moderation. I don't know if you understand what I'm saying. Some very complicated model like IV to M1, M2, DV. This we call serial mediation, right? This we call serial mediation moderated, right? This we call serial mediation double moderation effect. Okay, so in this kind of model, because it's very complicated, so that we have to already include the presumed understanding. For example, I already presumed how it will look like. Then I test it with Monte Carlo. Then it will have it. Okay. particularly, Monte Carlo is quite complicated to use. And I remember 5 years ago, we still have to use MATLAB, trying to test this one. And MATLAB is very powerful tool, but very complicated, so it's not popular. So luckily, we have Hades. Okay, so when it come out, it become like popular over the night. Within 1 month, it become very popular. Okay, so Monte Carlo, the strength in our field is that it's very data driven. Okay, so it will not introduce bias into your result. Okay, because you basically don't give it any presumption. Okay, so that's why bootstrapping perfectly fit in our field, social science and management. Okay, so this is a briefly explanation of the history. We go from Monte Carlo and we go to bootstrapping, and also because of thinking of Hayes, bootstrapping become more popular and very easy to accept, understand by everybody nowadays. So you can see that the complicated of your thesis become much more higher than, let's say, 10 years ago. Okay, because now we have the very simple tool to test the complicated hypothesis. Okay. All right, so what you need to know about bootstrapping? We already agreed that bootstrapping is very important and fit well into our need. So bootstrapping, generally, they will generate bootstrap confidence interval, CI. This is the most important thing. Okay, in SEM and in regression, we look for what? P-value. Okay, so in SEM and in regression and SEM, we will have beta values and p-values within the asterisk here, right? This is what we look for in regression and SEM. In bootstrapping, we look for what? Coefficient and LLCI and what? ULCI. Okay. So this is different a little bit. In bootstrapping, we do not discuss about p-values. Okay, we focus on this one, LLCI and ULCI. And for the strength, we do not call them beta, we call them coefficient. Okay. So this is the step of the bootstrapping. First one, the bootstrapping will create resample based on your original sample. Let's say, for example, you only have 100, they will try to generate more than that, depend on what you expect them. They can create 1,000, 5,000, 10,000, okay? So normally, for paper, we will expect 10,000, okay? And second, after they create the sample, they will calculate the parameter. This is the parameter. Okay, LLCL, ULCL, CI, sorry, LLCI and ULCI is the parameters. Okay. Yeah. So the important for you to remember, okay, for module A student, I expect you to remember that LLCI and ULCI must exclude 0. What does it mean? That means both of them have to be both positive values or both negative values. Okay. If one of them positive and one of them negative values, your hypothesis is not significant. Okay, remember? Okay, this is very important for module A student. Okay, so why that? Okay, let's go to a deeper explanation why it must exclude 0. Okay, do you know why? Module B student. Okay, so let's say the coefficient is, let's say, the effect of IV on DV. Okay, this is the again explanation. So this is just for your reference. Okay, so So you know that in bootstrapping they will generate coefficient, right? So let's say I read to mediator. Sorry, bootstrapping cannot test the direct effect. Okay, so this they have the mediation effect. They have one coefficient. Okay, so for one sample, you run one time, you will have one coefficient, one. And let's say bootstrapping will have you run 10,000 times. So how many coefficients you have? One sample, you have one coefficient. 10,000 times, you have 10,000 coefficients, right? All right. So let's say after they run 10,000 times, so they will create, let's say, the distribution. Okay. So the coefficient will change, not random, change based on this one. Let's say it can be 0.8, it can be by 0.9, something very small behind. Okay. But in general, the strength, they always, for example, the lowest one is 0.1 to 0.9. So that means IV actually have some strength on DV, and the strength is positive like this. Okay. Similarly, on the other way, if this is negative, everything is negative, then the strength will be negative 0.1 to, negative 0.1. Okay. In this way, the effect is negative, but it still has some strength. The strength is, the smallest one is 0.1, the highest one is 0.9. What happened if they have positive and negative in between?
It's indicate the lowest effect between IV and mini. But I mean it's near zero.
Very good. It's almost there. So right. So if does it happen that the range you see from this one is something negative, let's say 0.2, and positive 0.2. That means in 10,000, there's sometimes it happens with 0. In 10,000 times you rerun the bootstrapping, there is possibility that the strength, the effect equals 0. Means that there's no effect at all. Okay, so I actually currently I don't know how many percentage of 10,000 will have 0 effect. We don't know that, but we can say that it may happen that there is some situation there's no effect at all. And like I told you that researchers are very skeptical. If there's something not perfect, we will try to reject it. Okay, so only in 10,000 times, currently, if only one time it has 0, we still consider it not significant. Okay, that means if the range is one is negative, one is positive, there will be possibility that there is no effect, and therefore it will be insignificant. Okay, all right. So yeah, it requires a little bit of imagination. Okay. So anyway, the easiest way to understand for model A student, I just want you to remember they have to be both positive or both negative to be significant. Okay. All right. So don't worry, in the thesis final defense, professor will not ask you to explain this one. So you just remember this one. That will be good enough. Okay. So how to do that? This is the interface of the program. So earlier I saw you it stay right here, right? In the box of analyze, regression, and process. Currently, the newest version is 4.3, right? So you can upgrade it because the newer version they have some new models and quite useful for complicated models. So for the interface, there is several things that you need to remember. The first one, this is here. X variable which is IV, this YV. Okay. Y variables is DV. Okay. So you can see that the weakness of regression and bootstrapping is that they only can test one IV and one DV at one time. Okay. you cannot have multiple, for example, two IV on one DV, and then compare the effect. For example, like you have two antecedent, two IV, you want to compare the effect on the same DV. Bootstrapping, the process cannot do that. Okay, so that's the weakness. All right. The next box will depend on your models. Okay, so this box is for mediators. If you do not testing the mediation effect, you can let it just empty like this. Okay. Next one, covariant. This is your control variables. Okay, so age, gender, education. You will put it here. All right. And for the moderation, okay, they are more generous for us. They give it 2 slots so that you can test this kind of model, okay? Double moderation on the serial mediation, okay? So we can test the 2 moderation. For mediators, Hayes is the author process. He claimed that they can test up to 16 mediators. Okay, but if you test 16 mediators, your hypothesis doesn't have any meaning. Okay, it's more like trial and error. So normally the most we will do is 2 mediators. Okay. So the next one will be the model numbers. So this will be currently I think they have more than 90 models. Okay, but I think it's important to understand the basic. Then you can apply to all of the models. Okay. Next one is the confidence interval. Keep it like this, 95%. Do not touch it. Okay. Finally, is the number of bootstrap samples. Like I say, generally we require 10,000. Okay. But in today's demonstration, I only will choose 1,000 because to save time. But when you test hypothesis, try to run 10,000. Okay. I think all of your computer know what they can do that, right? Okay. In the beginning of time, when this come out and we attend some workshop, after every time we click OK, the teacher have to have a break because everybody have to wait for it to run. Okay. But now everything will be faster. Your computer is very powerful nowadays, so we don't need to wait anymore. Okay. This one, let's go through all of the picture first before I show it to you in the software. So for symbol moderation, did we discuss about the symbol moderation meaning with model A student? No? I remember last time I discussed it was in the Model B class, right? So we didn't have chance to talk about this. Okay. So for symbol moderation, you already understand IV to DV. Using path analysis or for Model A student, the only way you can test is the path analysis, right? So you already know this one. And let's say this one, the come out, the beta equal on, let's say 5 and 3 star. So that means it will go up because there's no sign here. That means we assume that it's positive and going up like this. This is what it happened with only IV and DV. Okay, so when there's some moderation up here, okay, it will change the strength of this. If the moderation effect is positive, okay, let's say the punctuate significant, this means that it makes the slope become strong. This is with moderators, this is with that, okay? So the positive this makes the slope become higher. That means when IV increase 1, the DV will increase a lot. Okay, so without the moderation, maybe they only increase, let's say 0.5, but now it becomes 0.8 when it increase 1. Okay, so this is the effect of the moderation. If the moderation is negative, okay, what will happen? They will reduce the strength, right? So now it is much smaller, okay? So you can see that 0.4. There is some situation that the moderation effect is so strong that it changes the effect. Let's say minus, we have no pen. So let's say minus 9. Sometimes if the moderation effect is so strong, it even can change the direction, okay, of the main effect, okay. But it rarely happens. The reason is if the moderation effect that strong, this one should be added. Okay, normally the reviewer will ask the same thing, right? If this one is so strong that it can change the direction of this, why don't you think this one is actually the real reason? Okay, why this one is the real reason? Okay, so that's why you rarely see this kind of hypothesis in the papers, except if you have very, very strong theoretical proof that this one should be the one. Okay, most of the time you will see the tree line. Okay, either increase or either decrease. All right, so this is the meaning of the moderation effect. Okay, so let's take a look at this. In this example, you can see that you have to check again. Okay, model one is testing the effect symbol moderation. You can see the S, LMS mean, the Y, human mean, and the moderators. Okay, then you also can check the control variables right here and the sample size. So after you quickly take a look at this, okay, nothing wrong, then you go to the result. All right. So you also can see they have the p-value here, but the p-value here in bootstrapping is not a strong evidence. Okay. What we want to see will be here. Interaction term. Okay, they will create that for you. And the interaction term effect on this is y, right? The interaction term effect on y do not include 0. Both of them are positive. This means the effect is significant. Okay, if you are not sure about what is the interaction term, you can check here. They already create for you. This is the product of the S and moderators. How about the coefficient? Here, column coefficient here. So, how to report this one? Okay, it will be the effect. Normally, you will say the effect is significant, blah blah blah, and the strength will be 0.5. Then lower one is 0.9 and 0.22, like this. This is how you report it in writing. Okay, but you also need to provide a table. Okay, the table will be here. Will be for this table. We will not include this one because this one will write the papers, write the test. The second part of the effect of the explanation of the moderation is that we have to check the slope. This is what I like about bootstrapping because they will directly have to check the slope. This one, compare 3 of this. For regression or SEM, you cannot do that. You have to test another thing to see we call that the slope analysis. But in bootstrapping, they will give it to us right here. Okay, they give us 3 lines. This is where the moderator is low, medium, and high. Okay, low means that it's almost there's no moderation effect at all. Okay, they will test where the moderation effect is smallest and whether it is significant and what is the strength. Okay, and the second one is when the moderation is mean, what is the strength, and when it is high, what is the strength. What you need to see here is that, okay, whether the effect become increased or decreased. Okay, so let's look at this. When the moderator become higher, the effect become stronger. What does it mean? This means that effect is actually the red line. Okay, so when this line is when there's no moderation effect, or we can say this is line where there's the moderation effect is at low, and this is where they are high, they move up. So that means we prove that the direction is positive. Okay.